So if any signal is receiving, because whatever air interfaces signal is there, it is in form of analog form. So our cell phone have the antenna, right? So if your mobile is new one, 5G supported mobile is there, then they have antenna for sub 6 gigahertz, yeah, you can say millimeter wave. So this is a sub 6 gigahertz antenna. This is you can say that millimeter wave antenna is there, connect in build in the mobile. Yeah, 4 cross 4 MIMO LTE signal, it is 4 cross 4 antenna is connected. Yeah, it is used transmitting for 2 cross 2, yeah, use receiving for 4 cross 4. So there's antenna is connected. So if any analog signal eNodeB is transmitting something, then you will receive by this antenna, whatever it is inbuilt in the mobile. After this receiving signals, they do the some process, RF process is happened. So in UE, there is two processing block is there. One is the RF processing block, another is the baseband processing block. Right. So first you will do the RF processing block if you is receiving something. Right. So if you is receiving something, then it do the RF processing, some RF processing. After that, if you is transmitting something, then baseband processing come in the picture. IP layer and application layer come in the picture, because if you are requesting from the network, you want to download some YouTube video, yeah, google.com. So application layer sent to the protocol stack, a protocol is sent to RF processing block. RF processing block sent to the eNodeB, then eNodeB process from the EPC and other core network is there, PDN gateway and PDN network is there, where it go and it request for the system. So now if suppose that our cell phone is receiving something, so first it will do the RF processing happen. So RF processing happen, there is some RF component is there in the mobile. So what the RF component is there? FEM is there, front end module. What front end module do? It find out the band information, right? This type of band is there in dual connectivity. Suppose that in CA case I am telling that, I was telling them two band is aggregating the bandwidth. So aggregating the bandwidth, so two band is there. Is suppose the band 40 or band 3, TDD and FDD is there. So this antenna is receiving both the signal, right? If it will receive both these signals, so FEM front end module, it will deal. It is implemented like a dual connectivity implementation is there. So in 4 cross 4 MIMO direction, yeah, 2 cross 2 MIMO direction, it find out those type of bandwidth, and you can say here in sub 6 gigahertz, in sub both are going in FEM. It also going in FEM. After that, it find out which type of band is there. After that, it going in RFIC. RFIC, what they do, it is responsible to receive and transmit the baseband signal, and also it used to different type of radio access signal. So what it is to do, it do the integrate whatever signal is received, right? So integrate on the chip to maintain a good RF performance. So it integrate with the chip, and after that it transmit to the baseband signal. So baseband signal, and after that you can see here in RF processing block there is a sensor is there. Here you can see LNA is there, low noise amplifier. So what the low noise amplifier, whatever it analog signal is receiving, it amplifying those signal. After that it transmitting to the RFIC, and RFIC those signal integrating on the chip. And chip, that means baseband signals. So in baseband signal, what is the use of sensor? Sensor actually it's used for the motion, but you is moving in different direction, right? In mobility scenario, you is moving in different location. Yeah, you can say the GPS sensor, health checkup sensor. So sensor is also there, and this is a baseband processing block. So what the baseband processing block is there? It support different band. Different band means band 3, band 3, 5, 40, whatever. India, mostly Geo operator use the band 3, 5 and 40. Airtel use the band 41, band 40, and 3 and 5 also use the Airtel. So whatever mobile is coming in India, so it support these band, right? So because these band are enabled for all the mobile, whatever it is in India. So whatever signal is coming from RFIC and integrated on chip. So after that, these are the RATs, NG, 5G has, these are the baseband processing block. Whatever signal is coming, it process the 5G related things. If it is coming, the LTE related signal are coming, then LTE have the baseband processing block. So how it is implemented, how it is developed, this processing block. It is developed, have you seen the protocol stack of LTE, RRC, RLC, MAT5? So these are developed in this processing block, LT processing block, 5G processing block. So whatever signal is coming from the sub 6 gigahertz, yeah, millimeter wave, right? So all the signals after coming to the RFIC, it is going on a specific RAT and transmitting to the specific RAT. And you can see also WC legacy RAT is there, WCDMA, GSM. So these are the RAT where after receiving the baseband, it process those signal and process those band, and it read whatever information is there in physical layer, read out those the things and decode those things. After that we see, right? If suppose that downloading the data, right? In downloading the data, so after RF processing block, it will come in below layer, and whatever signal we are using, it physical layer resource grid, it will map all the information, and after that we can read it, right? We can if we are opening read it those signals. And other part, you can see these are the non-3GPP some technology, their Wi-Fi, Bluetooth, GNSS. These all are also implemented on baseband processing block. So that is used for the main short range communication. We use the Bluetooth, GNSS, Wi-Fi. Other part is the, you can say in below, media core, application core, camera core, location core is available, right? Camera is there in your mobile. When you click on the camera, then this camera core application, it enable the operating system. After that you can able to open the camera. Yeah, in location core you are a map location, yeah, GPS you enable, then it enable the location cores. So these cores are also built in this band processing block. Yeah. So this is overall description about the cell phone block diagram. Next is this is the EnodeB block diagram. So how EnodeB look like? UE already you have told what the RF processing block is there, baseband processing block is there. In RF processing block, what the component is there? That component is your about mobile. What this type of which RAT, which technology support? If you have 5G supported mobile, you have, then they have a sub 6 gigahertz antenna and millimeter wave antenna. If LTE is supported, then 4 cross small MIMO, 2 cross 2 MIMO, this type of antenna supported is inbuilt in the mobile. FEM is there, RFIC is there in RF processing block. So LNA is there, low noise amplifier is there. So these are the component, or also other some component is there. So I have not mentioned all the component. So these are the basic component which we know. And after that, in baseband processing block, all the RAT supported your code is there, right? This 5G, LTE, other legacy network 2G, 3G is there. So because sometimes what happen in CS fallback is services, what happen, you are doing the some PS data, yeah, your mobile is connected through the LTE network, but when you do the call, it's moved to the 2G or 3G network. So how it is happened, right? Because it is connected to LTE and suddenly it is going 2G, 3G. So there is some processing block is there, software is there in mobile inbuilt. So that the block is doing those part. After that, yeah, now EnodeB, right? So EnodeB, you can see here, I think maybe you have seen the EnodeB, how it look like in tower, right? In tower, antenna is there, right? Antenna is one antenna is there, and this antenna near one RRH is connected, right? It is connected through the RF cable. And RF cable, it is connected 3, 4. So if suppose that TX diversity, then one RF cable, if 4 cross 4 MIMO, then all the 4 antenna will be connected. And here is once a CPRI is connected through the EnodeB. If EnodeB is there, this you can also BBU, we can say that. Yeah, EnodeB also you can say. So that is connected through the CPRI cable. Yeah, this is connected, one CPRI is connected here. CPRI is connected in eNodeB, and eNodeB one LAN cable is connected. We can say Ethernet, fast internet, gigabyte internet that is connected to EPC. So this is this type of you can see in physically, you can see in tower how it is connected. In lab environment also we can grow like this. So in yeah, so this this RRH is sitting on top of the tower. That means what is the use of RRH? You can see here this image RRH connected through the CPRI cable. It is connected in eNodeB in this spot. So I will come on eNodeB, but first we'll come on RRH. What is the use of RRH? RRH is responsible for the radiating the signal over the air, because this through this RRH antenna is connected. All RF cable are connected in antenna. So it is sitting on top of the tower that mainly perform the function and convert this optical signal to electrical and vice versa. It's the use. So in transmitter section of RF, what happen? It convert the digital signal to RF signal, because whatever signal is coming from eNodeB, right? eNodeB, whatever signal is coming through the CPRI cable, it goes in RRH in digital form. It is in optical form, but eNodeB generated as a digital form. eNodeB first it convert in optical signal, and that optical signal goes in RRH, and it convert in electrical, and then it convert electrical signal convert in analog form, and it sent to the antenna, and that analog is transmitted in that location, and you will receive the analog signal. After that, you will process those analog signal. So in RRH is made of, if you will see the internal diagram of RRH, then it look like it is CPRI cable is connected, and it is digital to analog converter, and and it is connected to power amplifier, and yeah, receiving low noise amplifier, and it go ADC. So and it is antenna is there. So if receiving any signal, they are transmitting any, it comes inside the RRH through the antenna. It's coming RRH where power amplifier, low noise amplifier there. If receiving, then it will come in low noise amplifier, amplify those signal and send to the ADC, analog to digital converter. So convert the analog signal in digital form, and through the CPRI cable it sent to the eNodeB. Through the CPRI cable. In same way, if eNodeB is transmitting something, so first it will convert in digital to analog form. Then power amplifier is there. Then amplify those signals and is sent to through the antenna. It transmit the signals. So this is the functionality of RRH. So it convert the digital signal to RF signal. That signal to amplify to the desired power level and antenna connected to it. So in receiver section, it will happen. It receive the desired band of the signal from the antenna and amplify it, and it sent to the eNodeB. So this is a transmitter, and reception is happened in RRH. After that, you can see here there is RRU. The eNodeB is connected through the CPRI connection, right? So why CPRI connection is required? So why actually? Because RRU, this RRH is often deployed far away from the BBU, right? BBU means eNodeB. That means here BBU is there, and RR is connected on top of the tower. So it is a little distance is there from the eNodeB. So that if suppose that you will put the RF cable, then its signal loss over the distance in case of RF cables. Because of that, we use the optical cable. CPRI connection have much less loss, and it is cheaper as compared to the RF cable. So because of that, because of losses, we use the CPRI connection between the eNodeB and RRH. Now come on the eNodeB part. So eNodeB, here you can see this image. This L8HU is there. This is the RRH, type of RRH is there. same RRH, this one is na. So we can say different type of RRH for the different vendor, equipment vendor is there. Nokia have the different equipment vendor. We can say RRH, different type of RRH is there. In other operator have the different RRH. So it is the HU RRH, which is connected through the EnodeB, through the CPRI interface, and this antenna RF cable is connected here and transmitting data. So whatever I have told here. So in this complete block diagram, you can see there is inline CA and UMA card is there. UMA card, they have internal design, internal component of you can say that EnodeB. L9 CA and UMA card is there. For the this is not a specific name. Actually, for the other operator, other vendor, different channel card name could be there. But for I'm telling about according to this image, suppose that one L9 CA channel card is in available in that EnodeB. So I will put this picture here. So here you can see in this image you have seen this one channel card, second channel card, and third channel card. 3 channel card is there connected, and below one is the UMA card. This one is UMA, and this one is this 3 channel card is there. Every channel card have approx 6 port is there. So when you will see this image, so in this image, this card, this complete is this below one, this is we say UMA card, that is management card, UMA card. This one is L9CA card. L9CA, you can say that B4F, some card name is there. This is L9CA B4R is there. Don't try to remember because it's not required. Just understand the concept of how it is designed and how equipment are there in EnodeB. If we are talking about the EnodeB, then which type of component is available, which type of hardware is connected. So this is a hardware name. So don't try to remember those parts. Just understand it, how it is designed and how it is constructed. So L9CB for your card, you can say that LCB3 card is there, right? So this L9CB4F card I am talking about. So this card is supported 2.3 gigahertz and 20 megahertz band we support. So how many cell we can grow for this this L9CB4? Total cell, here you can see this is the CPRI cable is connected for the. So how many CPRI we can connect through the RRH, right? So suppose that this first LAN cable, CPRI cable is connected, is RRH 1 is connected. So total how many CPRI we can connect? Total 6 CPRI we can connect, right? So 6 cell we can grow with this EnodeB from the one channel card. So this is the one channel card. This is the one channel card. From this channel card, total 6 cell we can grow, right? Because 6 port is there. Every port we can connect one RRH, right? So 6 port is there. 6 RRH will be connected. From here you can see total 6 is there. Here also we can grow the 6 cell and second channel card. In third channel card also we can grow 6 cell. So total cell we can grow 80 cell. Now we can grow the same band? No, it is not necessary. All channel card will support the same band. Maybe it is 2.3. It is support 1.8 gigahertz. 2.3 gigahertz, and this can be 850 megahertz. So maybe it could be different, depend upon the configuration on channel card supported. Maybe we can configure like all 3 channel card will be L9CA B4F. All will be band 40. That TDD supported. I want to put the channel card in all the port. So we'll remove this one and we'll put L9CA B4F. This one also will put L9CB4F. This one also will put the L9CB4F card. Yeah, we can connect another card. 1.8 supported card will put here, right? L9CB4R. That means that will be support the 1.8 supported cells. So we will connect with the RRH. Also a different type of RRH is there, right? So if I'm talking about the RRH. So it will also different type of RRH, TDD supported and FDD supported RRH is there. TDD support 2.3 gigahertz, FDD 1.8 and 850 gigahertz supported RRH is there. So we can connect this type of RRH in this port, right? So for all the port. If suppose that I want connection of carrier aggregation, I'm doing carrier aggregation. So I have combination of 3A plus 5A plus 40A, right? So 3A means it band 3A means band 3. This is a class. So band 3, that means it is 1.8 RRH is required. First requirement ki 1.8 RRH is required. 5A means band 5, that means 850. Band 5 class A, that means second RRH is required, that will support 850. So it is also RRH 850 RRH is required. And 40A, right? 40A is band 40, that is TDD RRH. So TDD RRH is required. TDD RRH is required. So total RRH is required, 3 RRH is required. So all three will be connected in top of the tower, and through the CPRI cable, it will connect it and go in this port. For the for 2.3 40A, it will go in this port, and for 1.8 it will go in this port, and for 850 RRH, it will go in this port. So it will connect it like that. So by using this method, we prepare the setup. If I need to do the 3CC environment, I need to create a 3CC environment, 3CA environment, right? Carrier aggregation. So from this method, we can prepare the setup. 3 RRH is required. So all 3 RRH will be connected in EnodeB in this port channel card. And this is a UMA card, right? This is management cards. Actually, you can see also here what the use of UMA card. So basically, UMA card is process the system and also used for the resource allocation and maintenance. If any alarm is coming because of due to the CPRI cable fault, due to the other long power issue related alarm is there, then this management card handle those type of alarm. And backhaul support, because eNodeB will communicate to the EPC network, right? So it should be connected through the EPC. So this LAN cable, this LAN port are useful to connect with the EPC. It will connect it through the EPC core network, and and also it will connected to the external monitoring. For the external monitoring, there is UD. Suppose because sometime what happened, EnodeB crash, not able to reboot. So there is some port is there. You can just log in through your laptop, and you can go inside the EnodeB, and you can do whatever you want to change some configuration. You can change it. So there is some LAN port is given. That purpose we can use it. And and also UMA is this board below board. This UMA board is useful for perform the communication path between the UE and EPC. Already have told for the Ethernet switching between the EnodeB and UE. And UMA is directly interfaced with the EPC through the the Ethernet cable. We can say that GE and FE. Fast internet and gigabyte internet, that is very high speed internet is there, that is connected through the EPC and EnodeB. And so this is the actually diagram. This is the internal physical channel card for the EnodeB. So what happened in LNICA? So I was telling a baseband processing block in UE. I was telling one baseband processing block is there. Once it received the analog signal, then convert in digital. After that, base processing block processing those signals and reading the information. So EnodeB also have baseband processing block. So that means say protocol stack related. We say RFA, RRC, RSC, MAC, PHY. So those all the things are available in L9CA card. this channel card inline CA card, that is for the 2.3 band, it is for the FDD, it is for the 850. So for the different channel card, different band, they have the channel card is there, where all the software is developed, protocol stack is there, software block is there, that is a processing for the transmitting and receiving the signal. So that is implemented, it is in EnodeB, or that channel card work for that. So inline CA modulate the packet data received from the UMA cards. Whatever actually it is, I have told, right, it is connected through the EPC, right? Any data is coming. Suppose the serving gateway, any data is coming from the serving gateway. So first it will go in UMA card, right? First it will go in UMA card. After that, L9 CA modulate those packet data received from the UMA and transmit it through the CPRI to RRU. It will modulate those signals and we will process those signal here in L9 CA and UMA card. After that, it will through the CPRI cable. Here CPRI cable, it go in RRH, and then RRH to go through the antenna, it go in air. So that is the way to transmit the signals. And after that, receiving the UE will receive through the antenna and log signal, UE will receive and it will process, and UE will convert analog to digital form, and after that digital form goes in baseband signal, and baseband block process those, and UE able to read all the data. So this is the process for the UE and EnodeB. Another part here. So this is the complete picture of data traffic flow.
And I would like to ask one question.
Yeah.
Yeah. Can you go to back slides?
Yeah.
Back, one more back. One. So I think that this DAC and AG would be part of your baseband module. It will be not part of your RRH module.
Which DAC?
Means digital to analog converter. And
Yeah. So this is the part of both sides. This is a part of RRH, digital to analog converter, analog to digital converter. That is part of RRH.
No. This in my understanding, when your FSP processor, it will go to your FSP processor, then it will do your IFT operations. So that is your part of your baseband processor.
Baseband processor, actually what happened, whatever electrical signal is there in EnodeB, that it will transmit through the CPRI cable, right? So CPRI cable, it convert electrical into optical signal, then optical signal goes in RRH and convert in electrical signal. After that, it convert in analog form, and then it transmit through the antenna. That is the way.
Yeah, so let me come back.
Maybe,
Because IFT, where is your IFT operation is done? Your FSP processor is your in baseband.
Yeah, maybe different vendor
implement OFDM.
Yeah, it depends upon the implementation. So maybe some vendor has implemented like that. IFT they have given in the EnodeB part. So that part also can be handled by our EnodeB if it is implemented like that. Then in that case.
Yeah, Shashwat, here actually what is happening?
Okay, so maybe we can park it for later, but we can check that whether DAC or AG is part of RRH or not.
Okay.
Yeah.
Yeah, in one more question I have in another side.
Yeah, Shashwat. Hello.
Please.
Yeah. Rahul here. Actually, right, this the RRH part, whatever Anand is saying. So what happens, right? This EnodeB and whatever the RRH, the communication is basically purely the digital communication. Okay. So when the RRH to when it goes to antenna, right? Antenna to UA, what is that is there? That is purely the analog communication. Okay. So what happens? Basically, this RRU will take care of the transmission from the digital to analog conversion. So that the UV and RF, whatever the radio part, right? The radio part, so that will be taken care.
So my understanding, this OFDM application would be happen on baseband processing.
Yes,
because
OFD.
FSP is if your RF is capable of baseband processing, then this DAG and AG can come in RRH.
Yeah, OFDM part happened in baseband processing block, but conversation, because you can't
when they will do OFDM, then only they do IIFT operations and FFT operations. Time to frequency and frequency to time conversion.
Actually, there is actually, I will explain that part. Actually, there is a
Okay.
digital up conversion and digital down conversion is there. So while it is receiving the digital baseband signal by digital up conversion and digital down conversion, it is changing in intermediate digital intermediate sample. That part, how it do it, scaling the sample rate of the signal, that it is changing in discrete format. Once it is changed in discrete format, after that through the digital and analog converter, it is sending in IF signal, analog signals. So that part is happened in RRH. Maybe I think you have a study, and it could be implemented on the basis of eNodeB. IF part is there, but here whatever I'm telling, it is the where RRH is handling conversion part, digital conversion.
Okay. Yeah. You can, in another slide, I have one more doubt.
Okay.
Can you forward one slide? So how you come to know this 3A would be like 1.8 RRH only will be used megahertz back.
Yeah.
You have shown this combination, na? 3.3A is 1.
Yeah.
How you come to know this conclusion?
Conclude, just I have given the one example. Is supported. I am doing
Okay.
the.
Means it can be other also 2.3.
Yeah, it can be also possible. It can be possible. 40 C can be possible. 40 C, right? 40 intra non-contiguous is there. Yeah, 40A also combination is there. If 40A 40 combination there, one both channel card will be TDD supported channel card should be there. If I am telling 3A plus 40C, then FDD and 2 TDD channel card should be there, then 3 channel cards should be there. So depend upon the combination, what scenario you have designed the test cases, right? So in test cases, what the configuration you have given, which type of band combination you are testing in your test environment. So according to that, you need to select the EnodeB, you need to put the channel card as per your scenario, and you need to test.
Okay. So it means there is no fixed mapping. 3A only 1.8 will be used, or it is like...
Yeah. If I am talking about band 3 means your one channel card should be a FDD support, 1800 megahertz supported channel card should be there. If I am talking about the 5A, that means it support the 850. Then one channel card should be a band 5. RRS should be band 5. So we need this type of equipment for my testing.
Okay.
Okay, I understand now. So it is not a fix. It depend upon the scenario. Configuration will be changed. Slot will be changed. Channel card will be changed. CPRI cable will be changed. RRH will be changed.
Okay. Thanks, Anand.
Okay. Yeah. Now actually, whatever I have shown, EnodeB side actually I have told, right. So EnodeB is there. So this is the EnodeB. We say CDU, RDU, different type of EnodeB is there. So actually this is the EnodeB blocks. So main processor block, channel card, CPRI conversion, in electrical to optical conversion, optical to electrical conversion. So it is connected through the gigabyte Ethernet. Fast in Ethernet, it is connected through the EPC, right? So once it is connected, then it go in main processing block, and main processing block sending in channel card, right? In channel card, it map the or whatever information